6-1 6-1 மணி என்ன கேட்டீங்க? பனீன
Hello all. It is 6:05 already, so let us start with the sixth live session for this. And since a lot of people are still joining, so I'll keep you all on mute. I mean, I'll keep this whole tab on mute. So I'll unmute it once we open the platform for interaction. Okay. So just keep your doubts with you till then. I'll just give me a minute. I hope you can share my screen. And first of all, happy Teachers' Day to all the people who are budding teachers of the future. So, and also the others. So, let's not uh, wait any further. Let's start. Welcome to the sixth live session of programming, data structures, and algorithms using Python. I'm Aditya, and let's just start. So. Yeah, so first for a quick recap of this, we saw backtracking with the example of n queens problem. So n queens problem is the most famous problem to explain backtracking. So backtracking is basically once you follow a series of steps to do something, then you hit some obstacle. So you think that okay, I have done this wrong. So you must have done that in when you have mazes. So when you solve mazes like connect dot A to dot B through this path, through this route, or you may have seen in your childhood that there is a mouse outside, and in between the maze there is a block of cheese. So draw the path that the mouse should follow to reach the block of cheese. So there you use backtracking. Backtracking as in you start a path, you keep drawing, and you take lefts and rights and whatnot. So if the path you've taken is wrong, if you've taken any wrong decision in between, you will hit an obstacle, you will hit a dead end. So what you will do, you will go back and you will wherever you have taken a right, now you will take a left and you will do that again. And if even here you hit a dead end, you will go back once again, and you do the same thing till you reach the goal. So yeah, in reality you will not draw that those many times. You will just do a visual inspection of what is going on and how you can do it. So all this you most of you basically do mentally. So that is one more example of backtracking. So backtracking basically is going back one step and rectifying your mistake and then proceeding. Okay. So and then we saw how we can use nested functions, how we can define functions inside functions, and then scope of variables. So global. So if I define a global variable within a function, I can call it outside the function as well, and I can use that value itself. Okay. So I'll define the function globally. So any other function also has the access to it, and my main code can also access that. Okay. And then how what the logic behind permutations is, we saw that. I mean when we calculate the next set of combination for a given bunch of numbers, when we calculate the next combination, when we sort or when we scan or whatever, or when we randomize. So permutations is for that. Then we saw what are sets, stacks, and queues. So sets are basically I mean, you must have done that in mathematics, set theory and all, Venn diagrams and all those things. So sets are, I mean, like they can also be classified as like lists. Okay, so sets was introduced to introduce the operations that are there with sets. So like and is basically the intersection, and or is union, then XOR and XAND and all those things. Okay, and minus was also there, saying that it is in my first set but not in second set. We'll come back to that when we solve the questions. And stack. So stack is a type of list where we follow LIFO. LIFO is last in, first out. So to visualize a stack, let's say you are at home, someone is making either dosas or chapatis, and you have a case, you have a casserole type of thing, and you put one after the other, and it's all ready, it's all made. So when you go and eat, what do? You take the top one, right? You don't take your hand, go to the bottom and remove that first. No, right? So that is how stack works. So in the stack, first in, whichever went in first is now at the bottom. So that will come out at the last. So last out. Sorry. So last in, first out. Sorry. So whichever one is at the top, that entered the stack at the end, and that will be the first one to exit it. And queues are also an example of lists where we follow first in, first out. So let's say you are at a bank, you see a long line, you were at some counter, so you join the queue. So the person who joined behind you will get his turn after you, right? So whenever you join, if you are the fourth person to join, you will be the fourth person to leave, given that you all are like equal people, and I mean the kind of work and the kind of work you need to get done from the back is also the same. So saying of equal people, if they're not equal, right? If someone has priority, some VIP has entered, so he'll be given preferential treatment and also priority queues we use when our it's not first in, first out. The exit will depend on the I mean will follow a set of rules. So the exit will be prioritized based on importance. So whichever work or task or person has more importance, he will be done first. So done as in that task will be completed first, and so that he can get out. So exit is preferential. Then we saw binary trees and heaps. So we'll solve some we'll write some functions on those. So I mean, I hope you, and I mean, I'm assuming that you have watched the week 6 videos, and since the deadline for the assignment is tomorrow midnight, I think, I hope you have attempted, on most of you also submitted that. So so as usual, so fine, let's go to our first question. Suppose A and B denote sets in Python, right? Under what condition can we guarantee that B minus A, sorry, B minus A equal to A? So this I am telling you once more. This double equal to means equivalent to, which is used for comparison. Single equal to is used for assignment. Okay, so we are comparing. In what case will this yield true, right? So when we compare two things, whether the comparison is correct, I mean whether it is true or false. So in what cases it is true? So the options are sets A and B are disjoint. Set A has to be a subset of set B. Set B has to be a subset of set A, and it is true for any values of A and B. Okay. So now I'll open the polls for. I mean, so read it carefully. Then I'll start the polls. So just give me a minute. Okay, wait. Ah, thank God. So I hope you can see the screen here, and I will open a poll now where you will have to answer. Okay, so question is there in front of you. So question is there in front of you, and so I'll not write the whole question again in the post. So I have launched the poll. The options are 4, 3, 2, 1. So the 4 means the fourth option in the question. 3, 2, 1. I mean, it should be clear, obvious. So it seems my camera has been off. So apologies for that. Yeah. So the poll will be active for let's say a minute. All right. Yeah, I hope you can all see the polls, and I hope the question is clear. Else, I mean, if it is not clear, then what's the use, right? So, and I also like really hope that you know what this minus sign means, because from what I'm seeing from the answers, from the live polls, it feels that you think it is mathematical minus sign. Anyway, uh, we'll come to it when you're done answering. So last 2 seconds. So time's up. Before that, does anyone have any doubts regarding the question? So yeah, first of all, most of you have answered it wrongly, because I think that you think that this minus sign is same as what we use in maths. So it's not. I'll end the poll here. So so if there are no doubts, I'll just go to the presentation. Yeah. So what was the thing? B minus A equivalent to A. So B minus A means, so I have two sets, A and B, right? They intersect. So this is the part in between is their intersection, and this whole thing is a union. Let's say this is A, this is B. Okay, my left one is A, right one is B. So B minus A means whatever is common in A and B, everything in B except that. So if you remove this intersection here and just this part of B, that is what is meant by B minus A. And our question says B minus A. So B is this whole circle. If I remove this part from this, so this, the rest of it will be B minus A. So B minus A will be just this intersection of A and B. Okay. So it says that intersection of A and B is A. When is that possible? That is only possible when A is a subset of B. Okay. So union of A and B will be B. Intersection of A and B will be A. So that is what. So uh, intersection of A will be equal to, sorry, intersection of sets A and B will be equal to A only if A is a subset of B, or it is also, I mean, subset also means if A and B are equal, like fully equal, all equal elements, same length, etc, etc, then also A can be called a subset of B, but then also B will also be a subset of A. So that's all. So A should be a subset of B. Okay, so most of you didn't answer it correctly. So please tell me if you have any doubts. We cannot see your screen. Uh, can't you all see my screen or what? I mean, my screen is basically the presentation. Just give a thumbs up if you can see my screen. The presentation where it says question 1 explanation. So it seems, yeah, so it seems that most of you can see my screen. So yeah, Janvi, there is some technical glitch on your end. Okay. Most of you had answered it wrongly. So if anyone has a doubt, please let me know. Else we'll just move on to the next question. All right. I mean, you have an option to raise your hand. Okay, never mind. Let's go to the next question. So yeah, we saw this. So next question is also related to sets, and this thing, this raised to the power sign. I forgot what it is called. So this is XOR, right? Exclusively OR. So just a minute. Yeah. So this exclusively OR is also, oh, okay. So and is and, I mean, and when you write the ampersand, right? That is and. Or is, you write or like this. Okay, this vertical line. So suppose A and B both are sets in Python. Okay, under what condition can we guarantee that A or B, so A or B is basically union, fine, A or B is equivalent to A XOR B. So A XOR B gives us a list of uh, all the all the unique numbers. So if A and B have 5 numbers in common, right? A has 10 numbers, B has uh, 10 more numbers where five are matching. So those matching 5 will be removed, and the rest of the 5 from A will be taken, rest 5 from B will be taken, and so since those are unique, right? I mean, it's there in A but not in B, there in B but not in A. So those will be taken, and then that will be my final set. I mean, that will be my XOR. So XOR is basically exclusively OR. So one more way to say XOR is OR minus AND. Okay, so OR is union, AND is intersection. So if I remove the intersection part from the union, only the non-intersected parts will be left, right? Only the unique values will be left. So that is basically exclusively OR. So I am doing OR, but I am excluding all the non-unique terms. So that is exclusively OR. So the options are here. A, B both are disjoint. A is a subset of B, B is a subset of A, or it is valid for all the values of A and B. So, so I'll make the poll live again. Give me a minute. Yeah. Yes. I'll delete this poll. Start a poll. So the poll has been launched. The poll is now live. So you just have to choose the answer. Okay. And unlike last time, I haven't put 4, 3, 2, 1. I've just put 1, 2, 3, 4. 1 means the first option. 4 means the last option. 2, 3 you can figure out what they mean. Okay. So I'll so please yeah, start voting, and as usual I'll start the timer for 1 minute. So Gaurav, XOR is exclusively OR. Okay. So exclusively. Okay. So the time is up. So wait. So Venkatalakshmi or never mind. So yeah. So XOR means exclusively OR. Exclusively OR means, so you know what is union and intersection of two sets. So okay, I'll actually explain it in the slide itself. So never mind. Have I ended the poll? I'll end the poll. Only one vote, and okay, never mind. Wait. Yeah. So see, I have two sets. So union means data in both the sets. Okay. So some will be without repetitions, of course. So A plus B minus A intersection B is basically a union. Okay. If we just check the data. So XOR, so it is also called OR. So if I say number 5 lies in either A or B, so if it lies in either one of them, that means my statement is true. That means OR is a union, and so if I say the number 5 lies in A and B, that means it has to lie in both. So 5 should lie in the intersection of A and B. So XOR is, I take the union and I remove the intersection part. So exclusively OR is, I am excluding all the common terms. So I'm left with only unique terms. Okay. So since the question said A or B, so the union is also uh, A XOR. So when is it possible? When A and B are disjoint. So that means so see intersection, sorry, union will also consist of the non unique terms. Okay. So the intersection part will lie inside the union, but I'm saying that both are equal. That means that part is 0. So they are not intersecting at all. So that means they are disjoint sets. So I hope it was clear. So let me go back to the Wait. Venkatalakshmi, just give me a minute. Yeah. Please. You can start speaking now.
The symbol given is it XR symbol, sir?
Yeah, that is the XOR symbol. So that is the XOR symbol in Python.
What is the AND symbol, sir? Common symbol.
And you know the symbol above 7 in your laptop. 7 is there, right? And you write
Okay,
ampersand,
okay,
right?
okay,
Uh,
okay, sir.
that is and. Union or is this one vertical line will be there above backslash. So enter is there on your keyboard, and above that backslash is there.
Okay, sir. I thought that it is AND symbol and I gave that answer, sir. Okay, sir.
No problem, no problem. You thought that that is AND symbol. A is a subset of B. So even if you thought that it is AND symbol, I think see, union and intersection will only be true when A and B are equal. Okay, so
Yes, sir.
A,
Yes, sir.
yeah,
Ah, yes.
So A is a subset of B means A can be smaller than B. It
Actually, I took only the option that is nearer to that one, sir. I know.
okay. Yeah, fine. No problem. But now, now if you understood, that's what counts. Okay, we have to. Yeah. Okay, cool, fine. So I think you have had enough of sets. So let's see what we have next. Right. Yeah. So I hope it was clear. And yeah. So now let's do something with heaps. Fine. So first, I hope you know what is max heap and min heap, right? Right. Yes. So min heap and max heap, you know. So and what is basically a heap? That's I mean you should know, but I'm still asking. So okay, fine, no problem. I mean yeah. So I have one max heap. So sorry. So I have a bunch of numbers. I have a list of values, right? So and I have some options. See, and as you can see, this list of values that is there, it does not represent a heap, but I can heapify it. Okay, I mean I can form it into a heap, and I can form it into multiple heaps. Multiple heaps, as in not parallelly. I mean into different heaps. I mean, if I change a few items here and there, the heap will still be valid. Okay, so I have four options in front of me, three of which are heaps, are valid heaps. One of them is not a valid heap. So your job is to find out which of them is not valid. So so the best way to, I think, do it, you can, I mean if you have code for this, very good. If you don't have a code, I mean the way I first started doing it was you take each option, draw the tree, I mean draw the heap, and then you see I mean then in between itself you will feel that no, it is wrong, and you will not have to, mostly you will not have to draw the whole heap. I mean yeah, but if the heap is valid, then you will have to draw the whole heap, of course, and then at the end you will realize that okay, this is not the right option. So I'll just keep the screen shared, and I'll just, so I said 5 minutes, but since I myself talked for around 2 minutes, I'll decrease the timer to 3 minutes if that is alright. Okay. And the meanwhile, if you have any doubts from the previous sessions, or I mean, so see, data structures is really important. This is so if you in future, if you're going for jobs and all, if you want programming job, see, software job and programming job is different. So for software jobs, you'll need whatever we did last week more, like file handling, how to use files, input, removal, and all that. Data structures is, I mean, so we have a lot of data, right? So data, abundant data is there, but to make it information, so information is meaningful data. So we want to structure our data in a way that it becomes meaningful. So that is the goal of this. So that is how programming works, and that structuring is, I mean, up to you. I mean, up to your requirement. Okay. So this is this week's and next week's videos are very important. So make sure that you watch them carefully, and whatever program sir may write in class, just write it yourself. I mean, copy that first, see how it works. I mean, go through that line by line, see how it works. See, because I'm saying that because the backtracking thing with n queens, it is quite complex. So I didn't get it in my first try. I had to understand. The logic is fairly simple, but the way the code has been written, you have to, I mean, read it a couple of times at least to understand how it works. Okay, so that's why I'm saying. Just, I mean, just for your information. So I have started a poll, and I hope the poll. Okay, wait, sorry, I have to launch it. Yeah. So I have started a poll, and I mean, just I hope you have tried out all the options. So just answer the poll. Just mark your answer in the poll. Right. So time's up, and yeah, I think people are marking now. Okay, so since one person just marked now, I'll extend it by 1 more minute. Yeah, so I think time's up. It feels like a game show actually. I'm giving questions with options, and you guys are answering. Okay. Anyway, I've gotten answers from all. I mean, in chat I saw 1, 4, 2, 3. So in the poll, most of you have answered it correctly. That is the third answer. So I don't know heaps. Uh, it is part of week 6 lecture, so I mean you should know. But anyway, in like quickly, I'll explain what is heap. So heap is binary tree, structured binary tree. So binary tree is where it's a tree, right? So it's a tree where two branches come, and from each branch, two more maximum of two branches can come, and wherever a branch doesn't come, it's called a leaf. So I start with, okay, I'll actually oh, I don't have the pictorial okay, just give me a minute. So I hope the screen is also visible. Yeah, it is. Okay, so this is called, the first one is called the root of the tree here. Okay, and for a heap and for a and each one will have two, maximum of two, and the way we assign it is top to bottom, left to right. So before giving this branch, I'll have to fill this. So I can stop here, here itself. I mean, these don't need to have any values. So if there is no child, so it's called a parent, and it's called left child and right child, right? So parent, left child, right child, parent, left child, right child. And one rule is that these two, not the sum, individually these two, their values should be less than this. So the child, a child's value should be less than the parent's value. So that is called a max heap, right? And in min heap, it should be more than. Okay, so maximum means maximum is on top, and minimum values or lower values are on bottom. No, maximum means only max is on top. Okay, and min means opposite. The minimum value will be on top, right? So this is like basically, yeah, so these are the values. So the first, yeah, so keep in mind one thing. So yeah, I'll bring it back, and the numbering is done like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I think I missed one number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, sorry, I'm really sorry. 0 1 2 3 4, yeah, 3 4 5 6 7, till 14. Okay, so now we can see that the two children are basically 2n plus 2 and 2n plus 1. So for 0, 2n plus 1 is 1, 2n plus 2 is 2. For 1, 1 2 3. So children of 1 are 3 and 4. Right, so 2n plus 1 is 3, 2n plus 2 is 4, and for 4 it's, and for 2 it is 5 and 6, right, and for 3 it is 7 and 8. So 3 is n, so 3 into 2 plus 1 is 7, 3 into 2 plus 2 is 8. So you have to just make sure that in the list that for n, 2n plus 1 and 2n plus 2 are lower than the value itself. So here the correct option is option C. You can see that you can see that 31 is more than 29, right? So I'll actually wait, I'm sorry, again it's here. Okay, so 97 goes on top, 83, just follow my pointer. Okay, so I'll, instead of that, I'll just use this 97, then 83 55, 83 55 72. I'm doing it with my mouse, so please bear with me. 31 45. Okay, wait, there is a small mistake somewhere. Forty-five, 29, 19, 31 and 28. So option C is doesn't look correct. So what else do we have? We have option B here. So 97, 55, 83, 29, 45, 72, 31. Okay, 72, 31, then 19 and 31. So 30 in option B, 31 is more than 29, right? So what is 29? 0 1 2 3, and 31 is 0 1 2 3 4 5 6 7 8. That means 8 and 3, that means 8 is a child of 3, and since 8 is bigger, and since 31 is bigger than 29, this value is, I mean, this option is the invalid heap. Okay, that is what we have to find out. So yeah, I'll delete this. Okay, so all right. So I'll yeah. So this option B is the invalid heap. Okay. All right. Now let's move on to the next one. Yeah. So after this, I think you will have to, not I think, I know, you will have to write a program of your own. Okay, so that will be the task. So just bear with me. Yeah. So consider the following heap, as you can see on the screen: 96, 96, 55, 74, 37, 42, 29, 18, 31, 19. It's called a max heap. I mean, it is categorized as a max heap. I mean, if you try it out, you will feel that it is correct, and I mean, you're free to do it once. Okay, so suppose we apply the operation delete max twice to this max heap, right? Twice. So the advantage of the heap is you don't have to find which is the maximum. Okay, we know that first element, as in the zeroth element, is the maximum, so we'll delete that. But then once that is removed, there is no root. Something will have to be the root, right? So instead of finding that which can be the next root, we'll just take the last element, make that the root, right? And then we'll compare. Then we'll check that if it is right. If I mean, of course, that will not be the final heap. So now we'll just have a bunch of values. Okay, so we'll heapify it. We'll compare and see that which one is. I mean, if its children are bigger, and we'll swap it with the larger child, and then we'll keep on doing that till the heap condition is met, till the heap becomes a valid heap. Okay, so I am doing this twice. Fine, I am doing this twice. So you have to find the resulting heap. Okay, so I hope the question is clear. So 5 minutes is, I don't think 5 minutes are enough. So I'll give you 7 minutes actually. Okay, so yeah, can you explain again the question? So who all has not watched the video on heaps? I mean, that is the last video of lecture 6. Just raise your hand, so give a thumbs up. Okay, don't raise your hand, actually give a thumbs up. So one or two people don't know what heaps is, and this makes it difficult because okay, anyway, I just explained heap to I think Gaurav said he doesn't know heap, so I just uh, oh Gaurav, oh, someone was unmuted, is it? Oh, I had muted the site itself, so I wasn't able to hear. I'm sorry. Uh, yeah, yeah. So, did you understand the question then, Gaurav? What you have to do? Okay, so can you explain it once for the class? I'll wait. I'll unmute this site so that I can. Yeah, yeah,
You want me to explain the question?
yeah. Like, what is what I mean by delete max? Okay, I hope you know.
So, for example, if it's a max heap or a min heap, whenever we delete something, it will always delete from the root. That's so. If there's a max heap and we say we want to delete the maximum value, we delete the root. Now, from that point on, what will the tree look like? That is your question. And what I know is that if you delete the maximum, then what we do is we take the last node and put it on the root, and from there we start bringing the we check we uh, we bring it down in ascending order, in the sense of we're going to bring 19 up, right, at the place of 96, and then we're going to compare it with 55 and 74, and then bring it down. I know that. Could you hear me?
My audio wasn't getting recorded for I think the last 1 or 2 minutes. Anyway, uh, if you have heard, that is enough. So I have started the timer, and the presentation screen is in front of you. The question is in front of you, and yeah. So please refrain from writing the answer in the chat. Poll is especially there for that. So please vote in the poll that which is the answer. So the timer is already in effect. So I'll yeah, I'll let you be.
Sir, poll means how to answer, sir?
Pole is not visible, sir.
It's visible. It's a,
It is in activities.
Yeah, let's see the answer. Right. So first I remove the 96. All right. Then I have 96. Then yeah. So 19 goes on top. Okay. 19 is on top. 96. And what is this? 55. So before writing anything else, okay, I'll write then 74, 37, 37, 42, 29, 18 and 31. Right, so 19 was here, now it is not there. So this leaf has been plugged now. So I'll compare these two, and since 96 is more than 55, 96 will be here. This will be 55. Sorry, this will be 19. Now I'll see 19, 74 and 37. So this 19 will be here. This will be 74. Right, because 77 is more than 37. And then I have 18 and 31, right? So this 31 is gone. This is now 19. This is now 31. Now I am doing the same thing again. So now my 96 has gone. 19 has come to top again. Once more, 19 is here. And this is now gone, okay? This leaf has been plugged. So 19 is here. So now 74 goes on top, 19 comes here. Now I'll compare 31, 37 and all. So 19 will come here now. This will be 37. This will be 74. Right. So basically now it is 74, 37, 55, 31, 19, 42, 29, 18. So option D is correct. Okay. So yeah. Any doubts here? Okay, some doubt. Okay, never mind. Option D. Yes, option D is correct. Okay, so let's move to the task. So we saw the logic of how delete max works. So now it is your turn to write its code. Okay, so write a function for delete max, and also heapify down, because once you remove that max, you'll replace it with the smaller one, right? Of course. So and then you will have to make it a heap again. So this delete max will call this function heapify down, right? So you'll have to define heapify down as well, and then you have to delete, yeah, so do this, right? And once you're done with that, subsequently, so once you're done with that, we'll discuss this, and I'll show you what the code is, how I wrote it. And you may have a better way, it's up to you. So once we are done with that, it's you also try, yeah, this is for the max heap, where the max sits on top. You have to do the same thing for, you can try to write a code delete min for a minimum heap and also a max heap. So finding a minimum in a max heap is sort of a little challenging. So you'll have to, but actually no, you can just find if you treat it like a list, just find the minimum, remove it, and then do heapify. Okay. Never mind. So I'll give you 15 minutes for that, for you to do it, because this is I mean, I don't know. So I have started the timer, and yeah. So then for the previous question, I hope most of you solved it by hand like I did. I showed in the thing, showed in the presentation. Now that you have written the code, you can just I mean, you know, you can just use the code for that. Yeah, I mean, once you'll be done, and if the code runs well. Okay, so to see if it runs correctly, just take those values from the previous question, feed it in the code, and if it matches, then it's fine. All right. So yeah, I've already started the timer. So yeah, and of course, if you're done within 15 minutes, just go stretch your legs, and I mean, because so much screen time is also not good. Yeah. So go straight to collab. All right. So, oh my god. Yeah, I'm using the same file as last time, so don't worry. That's why it's called 4 and 5. So since fourth session, I've been using this. Never mind. So wait. Okay, audio's on. So I'll call it. What was its name? Its name was delete max, right? And input will be heap. Yeah. So one thing, if I uh, so by to meet the syntax requirements, I need to put a colon here. If I don't put, see what it does. So it didn't align it here. I mean, you can see the when I hit enter, it went here, right? So, but what happens if I do put it? I have put it, so it automatically left a space and it brought my pointer here. So that is one more way to check. I mean, if you have to manually align it, that means you forgot something in the top line. Okay. So once I put colon, it identifies that I'm going inside it. So and in Python, inside it means, so it can be inside a function, a condition, a loop, or whatever. It just means I leave one space extra. All right, leave an extra space, not one space, one extra space. So extra, because already that thing itself might be inside a lot of things, so that must be four or five spaces from the starting. So if it is four spaces, the whatever is inside should be at least five spaces, right? So that's a one extra. So I I mean, I remember saying last time that for some reason sometimes it forgets to leave that space. So just to clear that air, I mean, I found it out. So my bad. I should have known this before. Okay. Anyway, so I have this. Uh, so let's define the length of the heap. Okay. So I mean, sorry. Okay, so first I have to check if the heap size is 0, right? So I mean, first I have to make sure that it is not 0, of course. So heap is my input. If it is 0, I'll say return. So none, you must have seen last time that none is just a variable if it doesn't have any value. So it just says that there is nothing here. So none means just return nothing, or I could have also written false here. Okay, so it's up to me. So as I said, commenting is very important. So when you will come back to your code again, you will read the comment, so you will not have to think too much that what is going on. Just write empty heap. Okay, so now I'll exit the if. So you know what is pop? So I'll so max element, right? So I'm calling it max L. I'll do heap dot pop. Okay. So one thing, so dot pop, what it does is from the list it removes the last element, but my max element is there on the top, right? That is my first or the zeroth element, right? Tech Technically. So pop will not work here. So what should I do? So what do we do? Once we pop that, we bring the last element to the top, right? So what we can do here is, I can write one line here saying heap, this is the first element, which is the max element, this is the last element, right? So I can write -1, or I can also write what is that called, len heap -1. That will be, I mean, I can, inside this I can write len, sorry, yeah, heap then -1, or I can save len heap as, say, some n, and then write that. But -1 is better. So -1, as you know, is basically counting backwards. So -1 is the last term, -2 is the second last term, like that. Okay. So I'll swap these two. So swapping, I don't need to introduce a third variable to swap, or I don't need to, I mean, jump through loopholes. I mean, give some plus minus and all to swap. So I can just write this. So this is now this, this is now this. So the smallest element, or sorry, the last element has become the root, and the root is now the last element. And so now if I do a heap pop, that last so the last element is now popped. So I am storing that the root as, I mean, the max element as max L. Okay. And now so yeah, so I'll just write one small thing here. I don't think in comments you need indentation all, but still. Okay. Alright, cool. Okay, so first, before anyone says anything, I'll just yeah. Did anyone say? Okay, fine. Yeah. So yeah, this much zoom is, I think, fine. Right. So now I'll just heapify it, right? So so I'm heapifying it from top to bottom. So my function is called heapify down heap, comma 0. So 0 is the starting, right? So first is 0, right? So yeah, but what is heapify? I have to mention what heapify means, right? So return, and also return what I have removed. Okay, then I mean, I should know, right, what I have removed. So now I'll do one thing. I'll just define this. I'll define this heapify down, and as input I'll take heap and index. Index as in from where I'm heapifying it. Okay. So what is it saying? Unintended amount does not match. Okay, fine. Yeah. So it's not equal to, sorry, syntax again. So now you see that whatever yellow curly line was here, that was also removed. So you don't have to, since it is in the same block, I can define this first. I mean, it will when it will reach this line, it will directly jump to this function since it's defined in the same block, or I can define it in a previous block, then link these two codes. I mean, I have to run that first, then run this first, or safer side, I'll define this function first on top, then bring this down to bottom, and then I mean, that way it will have read that function first, it knows what to do, and then it will perform whatever operation is needed here. Okay, so like we said, left child and right child. Okay, so uh, I'll put L child is sorry, L child index, right? So index, and let's write n here. Okay, n is better. So I'll just mention here n is the index. So n child, index of n child is of left child is 2n plus 1, right? Right child is 2n for nth parent. Left child is 2n plus 1 and right child is 2n plus 2. So 2n plus 1 and our child index. Okay, it's only the index, not the value. That is why I have written underscore n here, right? So 2n plus 2. Cool. All right. So next what? So the algorithm says I'll compare the first root or whatever parent is with both the childs. Whichever child is bigger, it will get replaced. Okay. So what will I do here now? I will just write if this is actually yeah. I mean I have to write the underscore again and again and again, right? So this is to check if it is still inside the heap, right? If I mean you'll know why I wrote this, because I'll be using a recursive call here. So yeah, I forgot to define one more thing. So largest one has to be on the top. Okay, so n is the index from which I have to start the heap. So the top. So top has to be the largest. So I'll just write largest equal to n. Okay. So we are assuming whatever is on top is the largest. Then when we'll compare, we'll see that if it is bigger or smaller, and then we'll swap accordingly and appropriately. So I'm comparing it here. Okay, why is there a red line separated by semicolons? Oh, the red line went. Okay, my bad. Yeah. So what happens here? I'll just swap the indices. Okay. So largest was currently at my index, where at the top. I mean top as in wherever I start the heapify. I'll replace it with the left child index, and same thing I'll perform with the for the right child. So I'll instead of writing it again, I'll just copy this, paste this, change the lefts to rights, of course. So I'm just seeing both. Okay, so if let's say both the children are bigger, then what will happen? So first I'll compare with left child. I'll swap. If right is smaller than left child, it's okay, fine, cool. If right is bigger than left child, they'll get swapped. Okay, so it's not an issue. Uh, okay, I'll also write it in another way. Okay, because this might give a small error. I mean, it will not give any error, but you might not be able to predict the result here. So you can still predict, but it will not follow the actual algorithm. So and then finally, so I hope you know what this means. sorry. Yeah, this means not equal to, right? So if my heap is already in the right order, that means these two will fail, right? And my largest will remain n, so I'm not changing. But if it is not in the right order, these two will pass, and I'll have to make the appropriate changes, the swaps I'll have to make, right? So to make those swaps, I'll just write, so n is still the top, okay, and largest is now whatever the index of the uh, largest number. I'll make the swap here. I'll swap the two numbers itself now, heap and sorry, so largest, and so now whatever the largest was, okay, no, sorry, this is actually correct, I'm sorry, this is actually correct. So since I'm not swapping the values here, I'm just assigning the index of the largest one to this. So if right side is bigger than left side, then that will become largest, that index will become largest, and whatever is the largest, it will just get swapped to the my top, okay. So so I hope this snippet is clear. And now since, yeah, if it is not true, I'll swap, then of course I'll perform heapify again, heapify down, so now I'll perform it from that point, right? So now n has become largest, and largest has become n. So so largest has come down, right? Largest was at the, yeah, so yes, correct. So now I'll perform heapify from that point onwards. Now let's just see if we can run the code. So I'll define this heap as heap1 is equal to, so yeah, I'll copy it from this thing, right? So will it let me copy? I have to check. So it's not letting me copy. So if one of you can write it in the comments, I'll as someone pointed rightly in the comments that our child is 2n plus 2. My bad. Thank you, Enos. Okay. So I'll copy. Let's see if I can paste it here. Ah, thanks. So yeah, I can remove these additional brackets. Yeah, this is my heap. So I'll do delete max once first. Okay, so del max is equal to, okay, what was the function called? Delete max, right? Okay, fine. Delete max heap 1. Then I can also print. So I'll do print element that was deleted is, so this was saved as what? As del max, right? Because it returned max help. So this del max is now basically the last element, sorry, the element that got deleted. And print new heap is, right. New heap is basically just heap 1 now, right, because sorry, yeah, so it sorted the heap in place, it heapified it in place. And see, now that I have removed the indentation, it means I have exited the function. So let's see if I have any errors. I've run the thing and I've got 9674. Okay, so I'll run it again. So yeah, just a minute. So yeah, so you might find that these two lines are the same, they look the same, but now that heap 1 has changed, it will perform it on the new heap 1. Okay, so I'll run it. So like we said, 74, 37, 55, 31, 19, 42 and 29 and 18. So that was the answer. So that means our code runs. And so any doubts? Any doubts on the logic of the code and how it works? Gaurav, just a second. Yeah.
Would you kindly explain the 3 if statements? That's where I.
Yeah, sure. So, okay, someone is not muted. Okay, they have muted themselves. 3 is state. Okay, so you, I hope you got this. So, n was the index, the parent's index. Okay, where I start the thing from. So what do I do? I compare them with my left and right child. So if parent's index is n, left child is 2n plus 1, right child's index is 2n plus 2, and I have saved that index in one variable called largest. Okay, so I'm assuming that the index of the largest in the 3 is n, is the current index. I start with the assumption that heap is in the right order. So I've saved largest as the parent's index. Now I'll check. So first, this one means that I'm just making sure that it's still inside the heap. Okay. See, because my largest will keep on so I'll keep on going down the heap, and I'll I'll just what is that called? Since I'm calling this function recursively, that means I'm going down the loop, down the loop, down the loop. At one point, when I'll stop, this condition will get sorry, these two conditions will not get satisfied. Hence, uh, this condition will also not get satisfied, and the heapify process will stop. I mean, that is the condition where both the children are smaller than the parent, right? So uh, this is just to say that I mean this index of this is less than the total length of the heap, so that I don't go out of bounds. Okay, let's say I've reached one leaf, right, the end. So if I do 2n plus 1, that will of course be less than the, what is it? Okay, yeah, if I have some point where it doesn't have any children, so it is at the end of the, what is it called? At the end of the of its line. If left has children, and yeah, so I'm just checking if it is still within bounds. Okay, and so if this is not satisfied, that means I have reached the end of that branch. I have reached some leaf, and yeah, of course, so it will not compute this. But if it is still inside, right, I'll see that heap value at this index, so value of the left child, I'll compare with the parent, with the parent's value that I've stored as whose index is n, and also currently stored saved as largest. So if this gets satisfied, if the child is bigger than the parent, I'll swap the indices. Okay, not the values yet. I'll swap the indices. So now the indices have been swapped. Now I'll compare with the right child. So if it has been swapped, I'll compare the left child's value with the right child, and if the right child is larger, one more swap will be there. Okay, so only the index values have been swapped, so the children are still at their place. So and then finally, since largest is not equal to n, I mean its value has changed, so the so swapping only indices, you might ask, we can swap the values here itself. So see, so that way I'll have to make a nested loop to first compare that which child is bigger, then swap with that, and then to see if that value is bigger than the parent, and then swap. So that can also be done, or I'm doing this. So I'm just swapping the indices. So now I know which is the largest child. Okay, so if the right child is the largest, I have saved that index and only swapped it with the parent. Okay, if I hadn't done that, if I had used the values directly, then my left child would become right child would become parent, and the parent would become the left child. But I don't want to disturb that order, so that is why I am only playing with the indices right now, and when it matters, I am swapping the actual values. Okay, so n and largest have swapped uh, the values at those indices. So if largest was now right child, I swap parent value and the right child value. That's all. So yeah. So now now then I'll recursively call the I'll perform that swap, and I'll recursively call this again. So see, the elements have been swapped. Okay, the index of largest, so the value at the largest has now become the parent, but the index of the but that index value is still the same. It is still pointing towards the right or the left child, I mean whichever. So from that point onwards, uh, I mean since I've swapped that, right, so the parent is now at that index after this swap. So from there I'll perform heapify again. So I've checked again with, if it has any children, I'll check if it is less or more, I mean if it is less or greater than the children, and I'll perform the swaps appropriately. Is it fine? Did you, I mean, is your doubt somewhat clear? Wait, yeah.
Yes, yes.
Okay, cool. Try it again, and try to write a code, I mean for min. Okay, so uh, oh, I thought I created one. Just a minute. Yeah, sorry. I thought I had created one repository where I'd upload all these codes. I think I am yet to do that. I'll just, so the repository is ready. I'll just upload the codes, and I'll share the link on the, I'll put the link on the drive link that has been shared to you. Okay, where I upload my presentations. So now let's just quickly go to the last question of the day. Yeah. All right. So task one has been done. Yeah. So now I have this heap. Oh yeah. So you insert dot insert. I didn't show. I mean, I'll either show that next class, or I'll leave it up to you. Okay. It's I mean, but the logic, I'll explain the logic, of course. So we want to insert 97 to the heap, this heap. What is the resulting heap? Okay, so insert, what happens with insert is it will insert it at the last position. Once that is done, similarly, so instead of comparing top to bottom, I'll compare bottom to top. So since 97 is obviously a child somewhere, I'll so wait, how many other, 1 2 3 4 5 6 7 8 9 10. So I will 0 1 2 3 4 5 6 7 8 9, right? So I don't want these, sorry, so I'll just cut this. Okay, so yeah, so the logic is basically, so this heap is like this. I'll insert 97 here, then I'll compare with the parent, then go back, then compare with the parent, then go back. Okay, so I have a resulting heap now. So I'll give you a minute or two, then I'll answer I'll ask a question in the polls, and you will have to answer that. Okay, welcome to the meet. So I hope, so now you have to on your pen and paper, using pen and paper or somewhere, if you have the computer, or wherever you find comfortable, just write the resulting heap. Keep it ready, because that is what I'll not ask you to mention the whole heap in the post. I'll ask some specific value, and you will have to answer that. Okay, so yeah, so I'll give you 2 minutes for this. So since we are running out of time, I'll give you 1 minute, and
Sir, shall we write the result here in the chat box?
I'm not asking for the whole result. I'll just ask for one specific element. Fine. So I'll just give me a minute. So I'll just make it live. Give me a minute. Uh, So I have launched the poll. You can see the answer. So the question says, what are the values at indices 2 and 8? So I mean, I don't need to tell you, but index 2 means third position, index 8 means ninth position. Okay. So the poll is now, I have launched the poll. If you have the new heap in front of you, you just see there, count, and write the appropriate answer. I mean, choose the appropriate answer. Or if you're not able to see the poll, just write it in the chat box. It's already 1 minute for this. Actually 30 seconds, because solving time was already there, right? Anyway, so seems, yeah, so 30 seconds are up. Someone has written the entire, so Prabhakar ELE, your actual, the answer is correct. That is the answer. So as you can all see in the chat, index 1 is 97. Okay, fine. So as you can see in the chat, Mr. Prabhakar has written the answer. So at index 2, that is the third spot, 9897, so it's 89. And at index 8, which is the second last spot, I have 25. Okay. So I mean, uh, insert, so basically, again, the logic is, wait, I'll just write answer, 89 and 25. Okay, I'll end the poll. 89, 25. Yeah, most of you have got the right answer. All right. So yeah, so just to explain it once more, this insert, I'll insert it at the end here, right? So yeah, so 98 was here. So since it is 98 is very big, so this will go untouched. I have inserted 97 here. So what was here? 97, 25, 17, 89, 54, 42 was here. So these two will get swapped. 42 will come down. Okay, 42 will not come down. I think 25 was here. Yeah, yes. 42 will come down here, right? So these two will get swapped. 42 will be here. 97 will be here, and here I think 67 was there, right? So now 67 will be here at I mean here, and this will be 97. So 98, 97, 89, and so on. Yeah, so I hope it was clear. And even today I wasn't able to do this. This was actually part of last class. It's a very interesting program. So anyway, thank you all for attending the class.
Sir, can you show the delete max once the slides delete?
The code,
Yes, sir. Yes, sir.
the code or the slide?
The
For
code,
me, maybe show
code,
the
code,
slide, the string slide as well.
code,
After.
sir.
Yeah, the code is here. So if you, since to make the whole code visible, I'll zoom it out so that I mean at once you can see the whole screen. So
Sir, only zoom the delete max.
delete max itself doesn't have much importance here. The heapify part is the main, and pop removes the last element, so that is why I swap first and the last element. Anyway, so I'll be uploading this to YouTube anyway. So just go to that, and I mean I don't know who all has watched that video. I mean the videos I'm uploading, but I have timestamps for all the things I'm doing. Okay, so timestamp timestamps where I'm explaining something, timestamps where I wait for people to solve. I mean where the meeting is idle, so you can just skip that if you want, and you can directly go to this. Uh, and this code I'll create a repository and upload to that, so you will have access to it. Don't worry. And yeah, so uh, now I mean I hope I mean just I just request that
That last string, that has been the last the question from last class that you had skipped. I had list has been problematic for me. Sure, I took a picture. Thank you.
Sir, the pop operation and push are fixed for the list, sir.
Thank you. Happy Teachers Day.